Okay, let's work out some problems concerning parabolas. We basically have two standard equations for the parabolas. We have two kinds of parabolas. Parabolas that open up and down, and parabolas that open left and right. For the up and down parabolas, the key is the x term is going to be squared. So here's the standard equation of an up or down parabola. And for the left and right parabola, the y term is squared. So now, based upon having the standard equation, we're able to determine the vertex, the focus, the directrix, and everything we need to actually sketch out and graph the parabola. So let's just do some examples. We'll go from pretty easy ones to a little more difficult. So the first example, we're given this equation and we're asked to graph it and find all the important information, the focus, the vertex, the directrix, all those kinds of things. So here's what I do. First thing I want to determine is this an up or down or left and right parabola? Well, since my y is squared, I know right away this is going to be a left-right parabola. Now, I want to make sure the parabola is in the standard form. Now, I'm going to rewrite this equation. It's pretty much in standard form now, but it may not be at first obvious what h and k are, because you notice h and k are the things we subtract from y and x, but there's nothing to be subtracted here. Well, that's correct, it's something being subtracted. But to make it very clear, how about if I rewrote it like this? Y subtract 0, quantity squared, and x subtract 0. In other words, the vertex is at 0, 0, since h is 0 and k is 0. The other very important thing we need to learn from the standard equation is the value of p. Although actually, before we do the value of p, let's talk about this. Now that we have this in the standard equation, the sign of this number, by sign I mean whether it's positive or negative, the sign of that number will determine in this case whether it opens to the left or to the right. If that number is positive, which it is, it's going to open to the right. So I circle that because in this case, this parabola opens to the right. If the number had happened to have been negative, it would have been a parabola that opened to the left. So far I've learned what my vertex is. I know it opens to the right. The next thing I have to figure out is I need to get the value of p. From my standard equation, the coefficient, the number in front of this parenthesis, equals 4p. And just by the way, just to clarify once again, for the standard equation, you have to make sure there is no coefficient, there's no number in front of the squared parentheses. The number or the coefficient has to be in front of the other parenthesis. So in this case, 4p equals 12. And if I solve for p, it's 3. At this point, I have everything I need to go and begin to graph this parabola. So let's do it. So first of all, I've got to keep everything straight, because when you do these problems, sometimes you get confused and you start graphing things the wrong way. Let's first graph the vertex, right? 0, 0. I'll even label it a V for vertex. Now I know this parabola is going to open to the right. It's going to look something like this. I'm now going to go graph my focus point, and the focus point is very easy to find. When you're at your vertex, you're going to move 3 points, or a distance of 3. You're going to move a distance of 3 to get to the focus. And the focus is always inside the parabola. So if this parabola opens to the right, that means my focus, I've got to move 3 in this direction. And there's my focus. As a matter of fact, if I want to, I can go and say, in case they ask, the focus is actually at 3, 0. Now, I'm going to go ahead and graph what's called the directrix, even though you don't really need it to graph the problem. A lot of times they want to see it, they want to know it. The directrix, you notice I move 3 to the right to get to the focus, and that 3 comes from my value of P. The directrix means you move 3 in the opposite direction of the focus. So if I move 3 to the right to get the focus, I move 3 to the left to get the directrix, and the directrix is actually a line. In this case, it's a vertical line. And the equation of that line is x equals -3. And that's my directrix. Now, I'm going to get ready to actually graph the parabola. All I need to know to be able to graph this is like the spread of the parabola, how wide or how narrow the parabola is. And with this information, it's very easy to determine that. Here's something, actually, it's called the latus rectum. Must be some Latin or Greek word, but actually, I like to use the word spread. In other words, how much does the parabola spread out when you graph it? And for me, now this is just for me, you won't see this in the book, this is how I do it. The spread is actually 2p. So in this case, it's going to be 6. Now let me show you what that number means. What I do is, I go to my focus, and the spread is how much? The distance. In this case, the distance I go up, and the distance I go down. So the spread, I'm going to my focus. My spread is 6, which is 2p. I'm going to move up 6. And that's going to be a point on my parabola. And then I also move down 6. And those become 2 points on my parabola. So I know my parabola goes through the vertex, goes through this point, and goes through this point. So now I can sort of try to make a rough sketch. It's not perfect, but that's the idea. So this is actually the equation, or the graph of the equation y squared equals 12x. So let's review quickly what we did, because we're going to do this a couple more times. You're given an equation, decide whether it's a left or right or up and down parabola. You get the parabola in standard form, and at that point, by looking at the coefficient, you can determine whether it's your left, in this case, left or right. So then you get the vertex. You can easily find the value of P. And once you find the value of P now, you can plot your vertex. With the value of P, you can easily find the focus. You can graph your directrix. And then you can figure out the spread, because you know the value of P. And graph these 2 points. And then do a rough sketch of your parabola. All right, let's do a couple more examples. I'll start a new piece of paper so I don't run out of room. So here's a second example of a parabola. This one's a little more involved maybe. X plus 1 quantity squared equals -4 y plus 1. So I look at this, and I notice right away that they've given me an equation that's in standard form. And as it turns out, the x term is squared, which means it's going to be either an up or down parabola. Now I go look at my coefficient here, and since it's negative coefficient, it's going to cause me to have a parabola that opens down. It's going to look like this when I get ready to graph it. It's going to open down. So now let's find the vertex, right? The vertex. Now this is a little tricky because remember the standard form is x minus h squared and y minus k. The standard form is minus and minus, so therefore when I have x plus 1 and y plus 1, my vertex ends up actually being -1, -1. All right, we've done that kind of thing before, like we talked about the center of a circle and some other things, so hopefully you understand that. Now we need to find the value of p. Well, I know 4p always equals the coefficient in front of that parenthesis, so therefore p is going to be -1. All right, I now have everything I need to go and start sketching out my parabola. So, my vertex is -1, -1. I'll label it vertex. Now I can always go and graph my focus point by looking at the value of p. Even though p is -1, I don't really care if it's negative. All I want to know is what the actual value, the number of p. I don't care about the sign. Even though p is -1, in my mind I think of p as being 1. Right? Because in this case, since the parabola opens down, I know my focus has to go down. Matter of fact, I shouldn't have put this V here because it turns out there's my, and let me draw, that's the focus right here. Since the P is 1 or -1, in other words, the P is -1, but I don't really care about the sign of P. I just need to know the value. So P, I think of as P is 1. I know the focus down. I know the directrix, I go up 1. Of course, it's right here on the x-axis, so it's hard to see. I'll try and draw it just right next to the x-axis. So that directrix, whoops, the directrix is going to be y equals 0. Now, if I find my spread number, then I can graph my 2 points and then finish this parabola. Of course, the spread is 2p. Once again, I don't care about the sign of p, so basically I just tell myself p is 1. I could say p is the absolute value of -1, which is 1, so the spread is 2 times 1. The spread is 2, so I go to my focus. In this case, I'm going to move 2 to the right and 2 to the left from my focus. And with my vertex and those 2 points, I can now make a rough sketch of the graph. And if they ask you, you say, okay, so the focus is -1, -2. If they ever ask you about the directrix, you can say it's y equals 0. And there you go. All right, let's do one more. And this last one is a little more involved because we're not going to give you the equation in standard form. X squared plus 4x minus 4y equals 0. Definitely not in standard form. Darken this up a little bit. It's like looks a little light. All right, so what do we do? Well, I know I still can quickly determine what kind of parabola, because here I have an x squared term, and there's nothing squared for the y. So x squared means it's going to be an up or a down. But now I somehow have to get this equation into the standard form. And in this case, what I'm going to do is I'm going to leave the x's on the left-hand side, move the y terms to the right-hand side, and now I'm going to complete the square on the x's. So here we go, x squared plus 4x equals 4y. Remember, we've completed the square before. You take the coefficient of this middle term, what I'm going to call the middle term, you divide it by 2, and then you square it. So 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 on the left-hand side, which means I have to add 4 to the right-hand side. And now on the left-hand side is a perfect square trinomial. Remember how these always factor? X plus the square root of 4, which is 2. This should be review. That's why I'm not going into a lot of detail on completing the square. We've done this before. Now on the right-hand side, you notice in the standard form, if I go look up here real quick, the standard form, it's always y minus k. I can't have a coefficient in front of the y inside the parenthesis. So therefore, for this problem, since I've got a 4 in front of the y, I actually have to factor out a 4. So I just get y by itself, and in this case, it'll be y plus 1. So now I've taken my initial equation, and I've rewritten it, and now I have it in standard form. And now once I have an equation in standard form, we know what to do, right? The vertex is going to be -2, -1. I know that number is positive. It's going to open up. Let me figure out my p. 4p equals 4, my coefficient. Therefore, p is 1. So now I'm ready to try and sketch this parabola. Vertex, -2, -1. I know it's going to open up, so it's like this. So now with my p of being 1, I can go figure out my focus. And since the parabola opens up, I'm going to move up 1 right here. So there's my focus. And now my spread is always 2p. In this case, it's going to be 2. Now from the focus, I'm going to go 2 to the right and 2 to the left. And now with those 3 points, I can try and draw my parabola. All right, so hopefully you're getting the hang of it now, and when you do the problems on your own, you'll be able to graph these pretty quickly.